Unit 1 is basically a review of everything they should learn in Chem 1, basically the first few weeks of Chem 1, and then some basic stoichiometry as well. So we're going to just kind of quickly go through this. I'm just going to talk through some of the terms, show you a couple significant digit examples, and then kind of move through here. So as you can see on here, physical and chemical changes. Physical changes are any change in matter that doesn't change the identity. So think about melting ice, water freezing. Any physical change is a phase change, and that's really what you're looking for. Chemical changes, you're looking for the change of identity of the substance, so iron rusting, an egg cooking, something along those lines. For the substance, element, compound, you're just looking for the distinction between a substance is anything that is a distinct properties. So something like water is a substance, sugar is a substance. An element is obviously the smallest portion of that can't be broken down any further, and a compound is some combination of those elements. For a heterogeneous mixture and a homogeneous mixture, heterogeneous, and the way I always remember it is hetero means two, homo or means different, homo means one or the same. So if you can look at the substance and see two different things, that's going to be a heterogeneous mixture. If you look at the substance and see one thing, that's a homogeneous mixture. Another name for a homogeneous mixture is a solution, which we're going to deal with a lot. So get used to those two kind of being using interchangeably. For the significant figures portions on here, as I scroll down a little bit on my, you can see on here, there's 5 different rules. Really, the big rules are number 4 and number 5, and I'm going to kind of switch programs here to go through those two things as well as the calculations. So, as you can see on here, significant digits, if there's a decimal point present, you start on the left, find the first thing other than 0, and count the rest of the numbers. So, I'm going to write out a number, maybe, there we go. So let's say we have 0.00251. So 0.0251 or 00251 does have a decimal point. So we start on the left-hand side because there's a decimal point. We go to the first thing other than 0, so 0, 0, 0. Here's the first thing. That means there are 1, 2, 3 significant digits. Okay? And you're going to follow that anytime there. It doesn't matter where the decimal point is. So if you have something like 1.35000 and they just keep on going, decimal point present, you start on the left-hand side, 1, first thing other than 0. So there's 1, 2, 3, 4, 5, 6 significant digits. Number 5 there says if decimal point is absent, you're going to start on the right, find the first thing other than 0, and count the rest of the numbers. So these are going to be bigger numbers generally that end up with this. So you're going to end up with something like this, so like 105000. No decimal point is present, even though it's assumed that it's right here. At the end of the number, because it's not actually formally written there, it means that this decimal point here was not measured, or this place value was not measured. So no decimal point present. You're going to start on the right-hand side because it's absent, and you find the first thing other than 0, which is this 5. So you have 1, 2, 3 significant digits. And that should be a review of Chem 1. It's pretty straightforward if you follow this rule. Decimal point present, start on the left side. Decimal point absent, start on the right side. It's sometimes called the Pacific Atlantic rule because if it's present, you start on the Pacific side of the U.S., which is the left if you look at a map. If the decimal point is absent, you start on the Atlantic side, which is the right of a U.S. map. As far as math with significant digits, we're not really going to concern ourselves too much with this throughout the year. As long as you're pretty close on most of them, I'm going to be okay with it. But we'll just go through the rules real quick. If you're going to multiply or divide, you want your answer going to have as many significant digits as the number that you started with that has the fewer. So let's say you had 3.501 times 0.002. Not really caring what the answer is at this point, you would just look and go, there's a decimal point present, so I start on the left. There are 1, 2, 3, 4 significant digits here. Decimal point present, start on the left. First thing other than 0 is the 2. So there's only one significant digit there. So what that means is when we put this in our calculator and we solve for the answer, our answer can only have one significant digit. For addition and subtraction, you're going to look at decimal places. This really doesn't get used a whole lot for us during the year, but I'll show you it real quick. Let's say you have, now we're not working, something like 15.23 plus 2.1. Okay, because I can actually do this one in my head, we'll do that is 17.33. Now, the way that this one works is you're looking for which one has the fewer amount of decimal places, or the least accurate decimal places, really how it's worded. And so if you look here, 15.23 goes to the hundredths place, 2.1 goes to the tenths. The tenths place is less accurate, or is not as many places past the decimal point as the hundredths. So what that means is your answer can go to the tenths place, which is right here. This 3 rounds down, so round out, and you'd be left with an answer of 17.3. Going back now to finish up, going through here with the rest of the notes, the SI units, pretty straightforward. You're not going to really need to memorize any of these because you're going to use meters for length, kilograms, you're going to use Kelvin, temperature. Get used to that, adding 273 to any Celsius temperature, and we'll do that so many times that it'll become ingrained in your head. All the prefixes are there. They're usually going to be given to you, so you're not going to have to memorize these. As we move forward, most of that stuff that was covered right there is in Chapter 1 of your book. The rest of this stuff is in Chapter 2. It's just some basic atomic theory, going through some stuff with number of protons, neutrons, electrons, that kind of thing. For Dalton's atomic theory, it's pretty straightforward if you look through there. It's all pretty common sense at this point for you, but at the time it was cutting edge. So matter made up of atoms, an element is all atoms that are similar, compounds are combinations of atoms, and a chemical reaction means that the atoms get rearranged. Again, all stuff that it's intuitive to you now, but at the time it was really kind of cutting edge. Moving down a little bit, as far as names that you may need to know for the future, Rutherford, there's always questions about his gold foil experiment, basically just shooting radiation into gold foil. Notice that some of it bounced back, some of it deflected, and some of it went straight through. And what that led him to believe is that there's a lot of empty space to let things go, the radiation go straight through, but there's also some kind of hard thing in there that's causing some radiation to rebound or to ricochet off in a different direction. J.J. Thomson discovered the charge of an electron. Usually it's just created, just the discovery of the electron is usually what it is, but it's the charge. Law of multiple proportions, pretty straightforward, that two elements can combine to form more than one compound. So you can see the examples: carbon monoxide, CO, and carbon dioxide, CO2. It's usually done in organic compounds, so things that are carbon-based. Because carbon can have 4 bonds because of its electron configuration, it allows it to do many combinations with the same element or different elements. The next thing here, and we're looking right in this area right here, is for atomic number, mass number, and a nuclide symbol. A nuclide symbol is this right here. Okay. If you notice up top, it's 23, on the bottom it's 11, and then Na. It has 3 parts. Up top is the mass number, 23, that is protons plus neutrons. That number comes from the atomic mass that's on the periodic table, rounded off to the nearest whole number. The bottom number is the atomic number, so that's just off the periodic table. And then obviously the symbol that goes along with that atomic number from the periodic table. Fractional abundance, we're going to spend a little bit more time with this in class, so I don't want to spend too much time with it here. But basically all that is if you look on the periodic table, you're going to find an atomic mass that's not a whole number. And the way that they came about with that is they found the 2 different types of isotopes. So same number of protons, different number of neutrons, so different masses of each element. And they found how often those isotopes occur in nature. Basically did some math. It's a weighted average, just like your grades are figured out, to figure out how they came up with that atomic mass. And like I said, we're going to do some examples in class, so we'll worry about how that goes about here in a little bit. Periodic table, you should have familiarity with that. Periods, the 2 big things here is periods. are the rows, groups are the columns. Sometimes they're called families, the columns as well, but know that the difference between a period and a group. Chemical and molecular formulas, really it's kind of simple there. Just looking down, you can figure that out. Ionic substances made up of a positive charged cation, a negatively charged anion. I always remember it with an anion is a negative ion. That works for me. Whatever works for you is great. You can see organic compounds we're going to get with naming there throughout this week. And those are basically anything that's carbon-based. And they have these functional groups, and we'll go with how to deal with all that coming up here shortly. And then as far as the naming and chemical equations, you have the packet passed out to you on the first day. Look through that. Make sure if you have any questions you ask. Like I said, Unit 1, all kind of review. This is just the basic terms in that. We'll deal more with the math here coming up in the next couple days.